Hey everyone, Mr. Mitchell here. We are going to move on to what would be our second unit of chemistry. We're going to begin looking over the next few days, and I guess the next few weeks, at the periodic table. A big question I get when we start this unit is, do we have to memorize the periodic table? And my view on that is no, you do not have to. The periodic table is a beautiful work of art. I can't emphasize that enough. There is so much going on inside it. Uh, just the way it's laid out tells us so much information. So is my aim over the next bunch of lessons to get you to understand how to use the periodic table. Once you understand how to use the periodic table, once you understand how to take the information out of it, then why bother memorizing it? You can Google it. You can have a picture of it, whatever. As long as you know how to use it, you're good. Why memorize certain facts from it? That being said, the more you use the periodic table, the more you become familiar with it, you'll actually start to memorize some elements and the information in them. So today, just a quick overview, and then tomorrow or next lesson, we'll start to unpack the periodic table even greater. So first of all, what's on the periodic table? The full name is the periodic table of elements. And what an element is, it's a pure substance that cannot be broken down into simpler parts. So in a pure gold ring, if you were to cut that ring in half, cut it in half again, cut it in half again, and you kept doing this over and over and over, eventually you're going to get down to 4 gold atoms. You cut that in half, you get 2 gold atoms. You cut that in half, you have another gold atom. And that's it. You can't go any further. You can't cut an atom in half. So once you get down to just one piece of something, one atom, that is an element. So a pure substance cannot be broken down into simpler parts as well. So water is made up of hydrogen and oxygen. So theoretically, you could break that down into just hydrogen and into just oxygen. If you have a pure gold ring with nothing else in it, you can't break that down anymore. It's just gold. So something like salt. Salt is made up of sodium and chlorine. You could take sodium and chlorine and you could break them apart so you have both elements again, but then you can't go any further. So when you can't go any further, that's an element. And these are the building blocks of all other substances. So all the things that you see on the periodic table, all those elements, those are the building blocks. Those are, I kind of refer to them as the Legos of the world. And you can take all those and you can put them together like Lego and build a spaceship. Then you can take them apart, put them together a little bit differently, and you can build a car. Take them apart, put them together a little bit differently again, you make a house. Same thing with elements. You put them together one way. So for example, you put a carbon and an oxygen together, you get carbon monoxide, a poisonous, dangerous gas. You pull those apart, put them together with a carbon and 2 oxygens. This time you have carbon dioxide, something totally different. That's that gas that you're breathing out right now. You take 6 carbons, 12 hydrogens, 6 oxygens, put them together, and you have sugar. You have sucrose. And as you take those same three ingredients, you put them together in a different way, you have vinegar. So everything is made up of these elements, these building blocks. And so we're going to look at that as well. Now, on a periodic table, you have the elemental symbol, and this is the abbreviation for the element. So oxygen, you'll notice in the periodic table, is just an O. So that is the symbol for oxygen. Helium is listed as He, gold Au. Some of these are make sense. Oxygen. However, once O is used, it cannot be used other times. So helium, you'll notice, is He. It can't just be H because hydrogen is just H. And when we, for the elemental symbol, if it's only one letter, it's capitalized. If it's two letters, as these two examples show you, the first letter is capitalized, the subsequent letters are lowercase. Helium makes sense. He in helium. Gold, where do we get Au from? Well, in that case, Au is from the Latin word aurum, A-U-R-U-M. And so some of our elements are taken from, say, their Latin derivative names. So the periodic table itself, every element is in a certain position for a reason, and we'll unpack that over the next couple days. But it's a system of organizing the elements into columns and rows so that elements with similar properties are in the same column. And the next lesson, actually, we'll look at 4 of those columns in more detail, and you'll see why they're in those columns. So I'm just going to flip ahead here too. We do have a periodic table. Here's a couple different versions of it. This one down here at the bottom, you can see that it has all the symbols. So H for hydrogen, He for helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, Na, one of those ones that don't seem to match up the letters, that is sodium, taken from the Latin root again. Likewise with K here for potassium. Other ones will do, the letters do match. So we have silicon here, and phosphorus, and argon, and krypton, and xenon. So sometimes the letters match, sometimes they don't. Here's gold down here. We talked about it earlier. So you can see with the periodic table, there's a weird shape here to it. And once again, we'll get into more why that shape exists over the next couple days. But there's a huge amount of information in these periodic tables and just the way it's laid out. The first primary way that it's laid out, you can see here, is we have this black line here is what we call the staircase. And everything to the left of it are metals. Even this, and this green square, these are metals. So everything on the left side is a metal, with the exception of this little guy right here, hydrogen. On the right side of the staircase, including these green squares, these are all non-metals. So that's the first bit of organization the periodic table does for us, is it organizes our metals and our non-metals into 2 different sides. So we talked about pure substances already, and pure substances cannot be broken down anymore. Compounds. Sometimes a pure substance is made of 2 or more different elements that are chemically combined, like water, H2O. But this can be broken down further. So we could break down H2O into just hydrogen and just oxygen. Or we could break down table salt, as I mentioned before, into sodium and chlorine. So a compound is when you have 2 or more elements making up something. Metals and nonmetals. So I just mentioned this already. Elements on everything on the periodic table can be divided into 2 groups: metals and nonmetals. So on the left side of that staircase, everything is a metal except for hydrogen. And on the right side, everything is a nonmetal. Now, what is a metal? Metals are elements that are hard, lustrous, which means shiny, malleable and ductile. Malleable, if you recall, means you can pound it flat with a machine, sometimes by hand too, and ductile, can you pull it out into wires. And metals have another property, that they conduct heat and electricity. So they allow heat to move along them very easily, and electricity as well. Non-metals, on the other hand, they tend to be either in gas form or a dull powdery solid. And they do not conduct heat or electricity. Now, I mentioned that the staircase shape here already. And these green elements along here, these are actually what are called metalloids. And they're up against the staircase because in the case of, say, silicon here, so it's this green one, silicon is on the left side of the staircase. It is clearly, or actually my bad, here's silicon right here. Silicon is on the right side of the staircase. The staircase comes down here, separating aluminum and silicon. So silicon is a non-metal. However, it does have a few characteristics of metal. It's silver, it's shiny, and it will conduct electricity. Not really well. It's what we call a semiconductor, but it will do it. Next door to it here, phosphorus. It is not shiny. It is not silvery. It does not conduct anything. Likewise with sulfur here. It's a dull yellow powder. Think almost that yellow Jello powder. Only it's a dull yellow, not a vibrant yellow. And it doesn't conduct anything. It's not shiny. But silicon, shiny, silver, somewhat conductive. So even though it is a non-metal, because it does share a couple characteristics of metal, it's sort of sitting right on the fence. So those are the metalloids. They're sitting right on the fence. They are either a metal or non-metal, but they do share some characteristics of the neighbor across the fence. And hence, a metalloid shares the properties of both metals and non-metals. What I'd like you to do too is, I'll try to send off a file if I can find a good one. If not, find a good periodic table that you can print. Now, I did find one here. This is not one that I want to print. That is, if you do have a printer. If not, find a good periodic table to download. But if you can find a blank one with no colors on it that you can print, and as I said, I'll try to find a file and send it to you if I can. It'd be handy to have. And a good periodic table is one that, as you can see up here in the legend, they will all have the symbol. So this is for helium. But there's two other pieces of information that you want on it. This 2 up here, this is the atomic number, and we're going to be using that a lot. It's very important. And this over here is the atomic mass. This is the weight of helium, 4.003. You want that as well. As I was going through Google Images, lots of different periodic tables posted for different reasons. Most of them had the atomic number, but not the atomic mass. But even quite a few basic ones didn't have those numbers either. You want to get yourself one of these that you can save to your photo roll on your phone or iPad, and definitely a good one that you can print off and even color in a little bit going forward, because we're not going to be using this whole periodic table, but we are going to be using parts of it. But you definitely want to have the atomic number and the atomic mass on it. So that is it for today. As you can see on here, a lot of information, lots of different colors, weird shape. Everything is in a place for a reason. We'll begin to look at those reasons a little bit later. But the first thing that you can see right away is, and it's not really bolded on here, but we do have this staircase separating metals and non-metals. So that's the first organization and classification of the elements. All right, till next time, have a great day, everyone.